You ever been completely stuck in a traffic jam, just staring at that angry red line on your phone? And you just wonder, how? How did it know this was going to happen before I even got here? Well, today we're going to pull back the curtain on the everyday magic behind Google Maps' incredible traffic prediction. Oh, we've all been there, right? You're running late, you check your phone, and bam, the ETA just jumped up by 15 minutes. It feels like it can read the future. But you know what? It's not magic. It's actually a brilliant system built on layers and layers of data. So, how does it really work? Let's get into it. All right, so the very first, most fundamental piece of this whole puzzle, it's not some secret network of government cameras or road sensors. Nope, it's you and me. It's every single one of us out on the road with a smartphone in our pocket. So the moment you have your location services turned on, your phone basically becomes this tiny, anonymous little scout. As you're driving, it reports your speed and your position back to Google's servers. Google then takes your data and combines it with data from thousands of other phones on the exact same roads. Each phone is like a single pixel, and together they paint this amazingly accurate, real-time picture of traffic all across the city.
Okay, but knowing what's happening right this second is just a snapshot, you know? To give you a really solid estimated time of arrival, Google has to do more than just see the present. It has to try and predict what's about to happen. And to do that, it needs to look to the past.
And this is where the whole system gets really, really smart. See, Google doesn't just look at what's happening live. It compares that live picture to a gigantic library of every traffic picture it's ever taken before.
Just think about that for a second. Google has this massive historical database that knows the normal, typical travel time for pretty much any road on the planet, for any given day, at any specific time. It knows exactly how bad the freeway gets on a Friday at 5 p.m. because it's seen it happen week after week for years.
So here's the secret sauce. Your ETA isn't just one thing or the other. It's this perfect blend of both. The live data is what spots that totally unexpected accident that just happened a minute ago. But the historical data? That's what predicts the soul-crushing rush hour traffic that happens like clockwork every single day. It's the combination of the now and the usual that makes the whole thing so powerful. But here's the thing. All that raw speed data, whether it's live or historical, it can't tell you why traffic is slowing down. Is it an accident? Or is it just a ton of cars on the road? For that kind of context, Google needed another layer of smarts. So back in 2013, it went out and bought itself a superpower. And that superpower was Waze. And this was a total game changer because it added the human element. All of a sudden, drivers weren't just anonymous little dots on a map. We became active reporters out on the ground, flagging everything from accidents and construction zones to stalled cars and speed traps. This adds that crucial why, helping the system know if a slowdown is just a little hiccup or a total nightmare. Okay, so let's recap. We've got live data from our phones, we've got a massive library of past traffic, and we've got real-time human reports. That is a seriously powerful combo. But to really predict your arrival time, say 45 minutes from now, the system has to do more than just report what's happening. It has to forecast. And for that, it needs a completely different kind of tool. And that brings us to the deepest, most complex layer of all, the predictive brain. The part that's actually trying to see into the very near future. This is where machine learning comes in. So, to put it simply, Google uses these incredibly advanced AI models that have been fed just unimaginable amounts of traffic data. These things aren't just following simple rules like if this, then that. No, they are actually learning the incredibly complex, hidden rhythms of traffic in a city. Also, they can forecast what that traffic will look like in the next hour. These models are juggling a ton of variables all at once. Current speeds, what usually happens at this time, the type of road, how many lanes there are, and so much more. The real challenge for them is to cut through all the noise of real-world data, to learn the difference between, say, one car just pulling over for a second and the actual beginning of gridlock. This is how it makes that educated guess on whether that little yellow patch up ahead is about to turn red or if it's going to clear right up. Now, what's so interesting here is that this graph shows you the core problem they're trying to solve. The relationship between the number of cars on the road, which engineers call flow, and how fast those cars are going, well, it's not a simple straight line, not at all. It's this messy, complicated curve, and machine learning is the tool that lets Google find the true pattern inside all that mess. And that brings us to the final, and maybe the most fascinating piece of this whole puzzle. It's a concept that traffic engineers are absolutely obsessed with, and it's the key to why this is all so hard. the critical difference between speed and flow. So let me ask you a question. If cars on the highway are moving slower, does that automatically mean the traffic situation is getting worse? I mean, our gut instinct just screams, yes, of course it is. But the reality, it's way more interesting than that. And this chart just nails the point perfectly. Take a look. The orange line is speed, and the blue line is traffic flow, basically how many cars are getting through over time. Right during rush hour, you see the speed, the orange line, just plummet. But look at that blue line. The flow is at its absolute peak. Here's the crazy paradox. When you feel like you're crawling, the highway is actually at its most efficient, moving the absolute maximum number of cars it possibly can. So getting this distinction is everything. Speed is just velocity, how fast a single car is moving. But flow, that's all about volume, or throughput. It's a measure of the entire system's productivity. As traffic gets heavier, cars naturally slow down and drive closer together, which up to a certain point actually lets more cars get through per hour. This super complex relationship is why just looking at speed doesn't work. But what's so amazing, as you can see here, is that traffic flow follows this incredibly consistent, predictable daily rhythm. It has its peaks, it has its valleys. This is the pattern that Google's machine learning models have been trained to recognize and ultimately to predict. They've learned the difference between a productive, efficient slowdown and one that's about to lead to a complete standstill. So next time you look at that ETA on your screen, just remember what's behind it. It's not magic. It's this incredible 4-layer system all working together. Real-time crowdsourcing, a deep library of the past, human reports from the road, and a powerful AI brain predicting what's next. It's truly an amazing piece of technology that's completely changed how we get around. And it leaves us with one last big question to chew on. For decades, the goal was always just to predict the traffic jam. Now that we've pretty much mastered that, what's the next frontier? Is it possible to use all this intelligence not just to route us around traffic, but to actually prevent it from happening in the first place? Definitely something to think about on your next drive.